Hello, in this video we'll be working through Unit 6 homework problems 20 through 34. And these problems deal with the fundamental theorem of calculus. For number 20, we want to evaluate the integral of t squared minus t dt from -1 to 1. So we're going to start by finding the antiderivative of t squared and of negative t. The antiderivative of t squared, using our reverse power rule, is t cubed over 3. Minus, and then the antiderivative of t is t squared over 2. Now we want to evaluate that from -1 to 1. So we substitute in our top value. We're going to put 1 in for t. We get 1/3 minus 1/2. Minus. Now we substitute in our lower value. So we'll put -1 in for t. And we get -1/3 minus positive 1/2. Then we have to distribute the negative over here. So I've got 1/3 minus 1/2 plus 1/3 plus 1/2. So my 1/2s cancel out, and 1/3 plus 1/3 is 2/3. And that'll be my final answer. Now we can check our answer on our calculator using Math 8. So what I'm going to do is enter my equation that I want to integrate in y1. So that would be my t squared minus t. Now you don't have to do that step. You don't have to enter your equation in y1. It's optional. So I'll show you two different ways. If we enter the equation in y1, then we can evaluate this integral like so. We'll use Math 9. And then we enter our bounds. So I want to go from -1 to 1. And then I want to enter the function that I want to integrate. Now I already have it stored in y1, so I simply have to call up y1 here. And then I'm integrating with respect to x. And I get an answer which is equal to 2/3. And we can convert that to a fraction. We see that it's 2/3. Now I could also, if I had not entered my equation in y1, I could have just gone Math 9 from -1 to 1 and then enter the equation here manually. So it would be my t squared minus t with respect to x. And we get the same result. Number 21, I want to integrate 3 over x squared minus 1 dx from 1 to 2. So I'll take the antiderivative of 3 over x squared, and I'm thinking of that as, maybe I should rewrite this in simplified form. So 3 over x squared, I'm thinking of that as 3 times x to the power -2 minus 1 dx. And now I can use my power rule to find the antiderivative for 3x to the -2. So that's going to be 3x to the -1 divided by -1 minus, and the antiderivative of 1 is just x. Then I'm going to evaluate that from 1 to 2. So I sub in my top number, and I might even want to simplify this first, make it a little easier. So -3, x to the -1 is -3 over x minus x. I think that'll make it a little easier to sub in our values. Okay, so we sub in that top value, we get -3 over 2 minus 2 minus, now I'm going to sub in my lower value of 1, so that's going to give me -3 minus 1. So I have -3 over 2 minus 2, and if I want to get a common denominator here, I can think of 2 as 4 over 2. So I have -3 over 2 minus 4 over 2 is -7 over 2. And then here I need to distribute this negative, so I have +3 plus 1. So really I'm adding 4, which is the same as 8 over 2, which gives me a final answer of 1/2. And we can check that here on our calculator, Math 9. This time I'm going from 1 to 2, and I'm integrating 3x to the power -2 minus 1 with respect to x. and I get 1/2. Number 22, we want to integrate u minus 2 over the square root of u, du, on the interval from 1 to 4. So before I find my antiderivative, I want to simplify this so that I can use the power rule. So I'm going to split this apart into u over square root of u minus 2 over square root of u. And then continuing to simplify, u divided by the square root of u is just the square root of u. U is the same as u to the power 1. Square root of u is the same as u to the power 1/2, and when we subtract our exponents, we just get u to the 1/2. Or you can think of u as being square root of u times square root of u, and we're dividing that by the square root of u, so one of the root u's just cancels out. Okay, and then the 2 over the square root of u, I prefer to leave it in that form. You can rewrite this as 2u to the negative 1/2 and use power rule. But I know that the derivative of square root of u is 1 over 2 root u. And so I tend to leave, when I'm trying to integrate something in this form, I tend to leave it in this form. If I can get it to look like 1 over 2 root u, then I know the antiderivative is root u. And I need a 2 on the bottom along with the root u. So what I'm going to do is I'm going to multiply the denominator by 2, but then I also have to multiply the numerator by 2 to keep that balanced. Okay, so let's see where we are now. I've got integral from 1 to 4. The square root of u, now I'm going to think of that as u to the 1/2, minus 4 over 2 root u. 4 over 2 root u, I'm thinking of as 1 over 2 root u times 4. Okay, let's go ahead and integrate this. So the antiderivative for u to the 1/2 is u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. Minus 4 is a constant multiple, and then the antiderivative of 1 over 2 root u is just root u. And we're going to evaluate that from 1 to 4. So we sub in the 4. I get 2/3, 4 to the 3/2. And we'll come back to that. Minus 4 root 4. Well, 4 root 4 is the same as 4 times 2, which is 8. Minus, now we're going to sub in the bottom number. So subbing in 1 is usually pretty easy. 2/3 times 1 to the 3/2 is just 2/3. 4 times the square root of 1 is just 4. Okay, let's continue to simplify. 4 to the 3/2. I'm going to deal with the 2 in the denominator first, and that's the root. And the square root of 4 is 2, and then I have to cube that, and I get 8. 8 times 2/3 is 16/3, and then I have minus 8. I'm going to distribute this negative, so minus 2/3 plus 4. Okay, the 16/3 minus 2/3 is 14/3. So I have 14/3, and then minus 8 plus 4 is minus 4. So I'm thinking of that as 14/3 minus 12/3, which is just 2/3. Final answer, 2/3. And we can check that here. Math 9, I'm going from 1 to 4. And I'm integrating u minus 2 over the square root of u. With respect to u. And of course the calculator is calling everything x. 0.6 repeating, that is 2/3. Number 23, we want to integrate x minus 1 over x squared dx from -1 to -2. So I'm going to rewrite this in polynomial type form so that I can use power rule. This is x minus x to the -2. Now the antiderivative for x is x squared over 2 minus the Antiderivative for x to the negative 2 is x to the negative 1 divided by negative 1. And we're evaluating from negative 1 to negative 2. Now, we say negative 1 to negative 2. We read this from the bottom up. But if you think about a number line, here's 0, negative 1, negative 2. We're integrating from negative 1 to negative 2. So we're actually going backwards here. We're going backwards. However, we don't have to make any adjustments. We can just follow our algorithm where we're going to substitute in the top value, minus, and then substitute in the lower value, and we will get the correct answer with the correct sign. So I'm going to substitute in negative 2 for x, and that's going to give me 4 over 2 plus negative 2 to the negative 1. We'll simplify that more in a moment. Now minus, and we're going to sub in our lower value. So negative 1 goes in for x, and that gives me 1/2 plus negative 1 to the negative 1. Okay, so we have 2 plus, raising to the power negative 1 is the same as taking the reciprocal. So I have 1 over negative 2, or just negative 1/2. And then I need to distribute my negative sign here. So minus 1/2 minus negative 1 to the negative 1 is just the reciprocal of negative 1, which is still negative 1, but I'm distributing that negative, so then plus 1. Okay, so these are like terms. Minus 1/2 minus 1/2, that's minus 1. Plus 1 is just 0, so my final answer here is 2. And we can check that using Math 9. We're going from negative 1 to negative 2, and we are integrating x minus x to the power negative 2 with respect to x, and we get 2. Number 24, we want to integrate 1 plus sine x dx on the interval from 0 to pi. So the antiderivative of 1 is just x. The antiderivative for sine x is negative cosine x. And we're evaluating on the interval from 0 to pi. So we're going to sub in our top value. We get pi minus cosine pi minus 0 minus cosine 0, which is pi minus negative 1, or pi plus 1. And then I'm going to distribute the negative here, so minus 0 plus cosine 0 for a final answer of pi plus 2. And checking that using Math 9, we're going from 0 to pi. We are integrating 1 plus the sine of x, make sure you are in radian mode, with respect to x. And that should be equal to pi plus 2. I can see that it is, but we can check. Pi plus 2. Yes. Number 25. We're going to integrate 3x squared plus 5x minus 4 on the interval from 1 to 3. I don't need to simplify this. I'm ready to go with my power rule. So the antiderivative of 3x squared is x cubed, plus antiderivative of 5x is 5x squared over 2, minus antiderivative 4 is 4x. And we're evaluating from 1 to 3. So I sub in the top number, 3. In for x, I get 3 cubed plus 5 times 3 squared over 2 minus 4 times 3. Minus, and I'm going to sub in the 1. So I get 1 plus 5 over 2 minus 4. Okay, let's distribute this negative and then simplify further. I've got 27 minus 12. So that's 17 minus 2, or 15. I still got this 45 over 2. And then I've got a minus 1 minus 5 over 2 plus 4. Okay, so 15 minus 1 is 14 plus 4 is 18. And then I've got 45 over 2 minus 5 over 2 is 40 over 2, which is 20. So my final answer should be 38. And we can check that using Math 9. We're integrating from 1 to 3, 3x squared plus 5x minus 4 with respect to x, and we get 38. For the next set of problems, we have the graph of a function f of x. We want to find the values of each of the following definite integrals. We don't have the equation, we have the graph, and so we're going to find these integrals using the area under the curve. For number 26, we want the integral of f from -4 to 2. And that's just going to be the area between the curve and the x-axis from -4 to 2. So we're going to break this down into recognizable shapes. We could go from -4 to -1 and say, okay, that's a trapezoid, and use the area of a trapezoid formula where we take the average base. The bases are 3 and 2. So we would do 3 plus 2 over 2, and then multiply by the height, and the height is right here. So that's a height of 3. So I can multiply by 3, and that's going to give me the area of that trapezoidal piece. You could also split it into a rectangle and this long triangle here, and that will work as well. So for the rectangle, we have an area of 6. For the triangle, when I have to find the area of these triangles, I usually just make it the rectangle and then cut it in half. So this is half of a 1/3 rectangle, so it has area 1.5. And then this triangle right here is half of a 1/2, so it also has area 1.5. No, 0.5. No, 1. What am I saying? A 1/2 rectangle has area 2. Half of that is 1. And then from 0 to 2, I can split that and say, well, this part has area 1 and this part has area 1. Now, the other thing I need to be careful about is that these are signed areas. The area above the x-axis is positive, the area below the x-axis is negative. So this 6 is actually an area of -6, and this is a -1.5, and this is a -1. But above the x-axis, we have positive areas, so 1 and 1. Okay, so putting this all together, I guess I should continue writing this out over here. I had my trapezoid, and then I would subtract the 1 for the extra triangle, and then I would add the 2 for the parts above the x-axis. And we get -6.5. Number 27, we want to integrate f on the interval from 0 to 3. So from 0 to 3, now we also are looking at this piece here, and this is half of a 1/2 rectangle, so it has area -1. So if we're going from 0 to 3, we have 1 plus 1 minus 1, which is just 1. 28, we're going from -1 to 1. So from -1 to 1, we have -1 plus 1, or 0. We're finding net area here. Number 29, now this one's a little different. We're not integrating f of x here, we're integrating f prime of x. So we're going to use the fundamental theorem of calculus here. I know this integral is equal to the antiderivative of f prime, which is just f, evaluated from -4 to 0, which is f of 0 minus f of -4. And the values for f I can read from the graph. F of 0 is 0. F of -4, right here, is -3. So 0 minus -3 is just 3. Number 30, I'm integrating f prime dx from -1 to 1. So that's going to be f of x evaluated from -1 to 1. So f of 1 minus f of -1. F of 1 is 2 minus f of -1 is -2. So there we get 4. And 31, we're integrating f prime on the interval from 1 to 3. So we get f evaluated from 1 to 3. So f of 3 minus f of 1. F of 3 is -2. F of 1 is 2. So here we get -4. 32, we are told that the integral of f from -2 to 6 is 10, and the integral of g from 2 to 6 is -2. We want to find the values of each of the following definite integrals. So we're going to be using some properties of definite integrals. Part A, what is the integral of f plus g from 2 to 6? Well, that's the same as the integral of f of x dx from 2 to 6 plus the integral of g of x dx from 2 to 6. And we were given the integral of f from 2 to 6 is 10, and the integral of g from 2 to 6 is -2. 10 plus -2 is 8. Part B, the integral from 2 to 6 of 2f minus 3g. So using our properties, we can split this up and we can take our constant multiple outside of our integral. So it's 2 times the integral from 2 to 6 f of x dx minus 3 times the integral from 2 to 6 g of x dx. So 2 times 10 minus 3 times -2. 20 plus 6, or 26. Part C, we can use our constant multiple property again and bring the 6 outside of our integral. And this one is asking us to integrate from 6 to 2. Well, I'm going to flip those bounds and go from 2 to 6. And when I do that, I have to multiply my result by -1. G of x dx. So that's -6 times, and I was told the integral from 2 to 6 of g is -2. So -6 times -2 is 12. Part D, the integral from 2 to 6 of g of x over 2 times f of x. Well, I can bring the 2 out. It's in the denominator, so it's still in the denominator when it comes out. So I'm bringing out a 1/2 from 2 to 6, g of x over f of x dx. Well, we've seen properties where we can split integrals when we're adding or subtracting, but not when we're multiplying or dividing. We don't have any property that is going to allow us to evaluate this based on the information that we know. So this one cannot be determined. So be careful about splitting up your integrals. It's only going to work with addition and subtraction, not with multiplication or division. Unless you're just multiplying or dividing by a constant. That's different. That's what we mean by constant multiple. Number 33. Given the integral of f from -2 to 4 is -6, and the integral of g from -2 to 4 is 4, find the values of each of the following definite integrals. So we'll use our properties again. Part A, since we have f plus 4, we can separate this into 2 integrals over that same interval. So the integral from -2 to 4 f of x dx plus the integral from -2 to 4 of 4 dx. And we're told the integral of f from -2 to 4 is -6. But we have to find the integral of 4 dx from negative 2 to 4 ourselves. So the antiderivative of 4 is 4x, and we're going to evaluate that from negative 2 to 4. So we get negative 6 plus, and then I sub in my top number, 4 times 4 is 16, minus, sub in the bottom number, 4 times negative 2 is negative 8. So that's 16 plus 2 is 18. Part B, 3g of x plus x dx. We're integrating from negative 2 to 4, so I can use my properties here. I can separate this into two intervals at that plus sign, and I can use my constant multiple property and bring the 3 to the outside. So 3 times the integral from negative 2 to 4, g of x dx, plus the integral from negative 2 to 4, x dx. We were told the integral of g from negative 2 to 4 is 4, so I have 3 times 4, plus, but we have to find this next integral ourselves. The antiderivative for x is x squared over 2, and we're evaluating from negative 2 to 4. So we get 12 plus, I sub in the 4, I get 16 over 2, minus, I sub in negative 2, and I get 4 over 2. So this is 12 plus 8 is 20, minus 2 is 18. And part C, again, we can separate this because we're adding two terms. So I get the integral from negative 2 to 4. I can bring the 1/2 out, integral f of x dx, plus, and then I can bring the 3 out and integrate x squared dx. So 1/2. The integral of f from negative 2 to 4 is negative 6, plus 3 times, and I have to integrate x squared myself. So x cubed over 3, and we are evaluating that from negative 2 to 4. 1/2 times negative 6 is negative 3, plus 3 times, now we sub in the 4, so 4 times 4 is 16 times 4 is 64, so 64 over 3, minus, and then when I sub in the negative 2, I get negative 8/3. So negative 3 plus 3 times 64 plus 8 is 72. 72 thirds. Oh, and our 3's cancel out. So negative 3 plus 72 is 69. And finally, number 34. Pictured below is the graph of f prime of x, the first derivative of a function f of x. Use the graph to answer the following questions. So first, we want to determine the value of the integral of f prime dx from 0 to 7. This is the graph of f prime. So if I want to integrate f prime, I'm looking for the area under the graph of f prime from 0 to 7. From 0 to 7, we can split this into geometric shapes. So the first triangle here from 0 to 3, that's half of a 3 by 2 rectangle. So the 3 by 2 rectangle has an area of 6, half of that is 3. So this segment has an area, or this region has an area of 3. And then I have from 3 to 4, that's 1.5, because it's just one square and then half of a square. From 4 to 6, that has an area of 2. And then from 6 to 7, I've got this one square right here, and then half of a 1 by 3. So half of the 1 by 3 is 1.5, plus this one is 2.5. So the value of the integral of f prime of x dx from 0 to 7 is just the sum of those areas. 3 plus 1.5 plus 2 plus 2.5. So the 1.5 and the 2.5 is 4, 5, 6, 7, 8, 9. Part B, if f of 0 equals negative 3, what is the value of f of 3? So remember that the integral of f prime of x dx from a to b is equal to f of a Nope. F of b minus f of a. We take the antiderivative, which is just regular old f of x. We sub in the top value, minus, and then we sub in the bottom value. So to answer this question in part B, notice we have here f of 0 and we have f of 3. So we're going to set this up to be the f of b minus f of a here. So I want an integral that goes from 0 to 3. If I integrate f prime of x dx, that's going to equal f of 3 minus f of 0. I already know that f of 0 is negative 3, and I'm trying to solve for f of 3, and I can figure out the integral on the left using area. The area under f prime from 0 to 3 is 3. So we have 3 equals f of 3 minus, and then f of 0 was given to us as negative 3. So if I subtract 3 on both sides now, I get f of 3 equals 0. Part C, we have f of 3, and I want f of 7. So I'm going to set up my integral to go from 3 to 7 of f prime, because that's going to equal f of 7 minus f of 3. The integral from 3 to 7 is just going to be the area under f prime from 3 to 7. So from 3 to 7, we have an area of 6. So 6 equals f of 7 minus f of 3 was given to us as negative 1. Now I subtract 1 on both sides, and I get f of 7 equals 5.